Hello everyone. In our previous lecture, we covered bubble sort and selection sort. Today, we are going to dive deeper into the two more important sorting algorithms. That is, first one is the insertion sort, and another one is the merge sort. These algorithms are not just theoretical but have practical uses in real world application. So, without wasting our time, let's get started. The first one that is, we will talk about insertion sort. Okay, imagine you have a deck of playing card in your hand. You pick one card at a time and insert in it into correct position related to card you have already sorted. That's how insertion sort work. It's build the sorted portion of array step by step. So the definition of this like is that this algorithm work by taking each element and inserting it into its correct position in a sorted portion of the array. Okay, like we are taking one example that is with a small array, that is we are taking an example of size 5, that is 5 comma 3 comma 8 comma 4 comma 2. We started with the second element and compare it with the element before it, and then inserting it in the correct position. Okay, so let's look at the code for insertion. So we will move toward our editor. So we'll wait a second. Yeah, so this is our insertion sort code, and the below is the merge sort. I will comment it already. Just write it as like merge sorting. Okay, so we start with the second element, that is index 1. Okay, the element is compared with the first element, that is we are comparing this with this. Okay, and if it's smaller, it's moved to the left. This continue until the entire array is sorted. Like we are taking this example of 53842 example. Okay, so the first is like 3 move before 5. Okay, that is we get 3 5. I will write it here, that is in the comment we get first move. First move we get 3 5 8 4 2. Okay, this is our first move. Then it stay in place, like 8 is greater than the 5. Okay, so 8, no change in that. Then 4 move between 8 and 5, that is the 4, this one is less than this, so it's again, that is we say third, and it's now that is 3 comma 5 comma 4 comma 8 comma 2. Okay, this is for third one, and then again 2 move to the start, that is the last one, that is 2 move to the start position. That is our again command we get, that is 2 comma 3 comma 4 comma 5 comma 8. Okay, this is how the sorting insertion sorting work. That is, insertion sort work well for small database, or you can say dataset, or nearly sorted data. But for large dataset, it's not the most efficient with a time complexity of O naught n square. Okay, so that's why we use the other sorting algorithm. So I was so let's run the code and we get 2 3 4 5 8 as per our last step, that is 3 5 2 3 4 5 8. Okay, I hope you understand this one. So let's remove it out, this one, and we are moving toward our next, that is where is our editor? Yeah, so the next is merge sort. Okay, so let's go first definition of merge sort, that is it's a dive and conquer algorithm. It's divided the array into small subarray, sort them recursively and then merge them. Like if you have something like chocolate, we are taking a per, then you divide it and distribute it to each, like it's a part 1 and this one is a part 2. Okay, so let's take a small array example again for this as well. Right now we are taking an example of like take a random value, that is 38, 27, 43, 3, 9, 82, 10, like that. I don't know the what exactly the size, that is 1, 2, 3, 1, 2, 3. 4, 5, 6, 7. Yeah, the size is 7. Okay. So let's go to our editor again, like how we implement the code. And first we will explain the code to you, then we will run the code. Okay. So in this code, the merge sort function, that is this one. Okay. Recursively split the array into two halves until each subarray has only one element. Then the merge function combine this subarray back together in sorted algorithm. So let's see how merge sort work on the array. Like as per the insertion sort, we already take like what exactly that means. Okay, so in this we are again writing that. So let's yeah. So this is the entire code of this. So make sure to check all this code and one by one. And if you did not get anything, you can just drop your comment. I will help you and tell you what exactly is doing and solving your query. Okay. So the first step, that is it's dive into two halves. The first one, that is we are taking 38, 27 and 43. Okay. This one is the first, and the next is, that is 39, 39, 82 and 10. Okay, this one is the second half. Okay, first step is over. Then recursively dive each half until you have single element. So again, what happened? It's again divided this work like, it's divided it like 38. Then again take a comma 27. Then again it's take this one, and then it's like he divided the work into these two pieces, like, or we can say like 27, then it's 43. Okay, this one, and then again 3, then we are taking a 9, like, or we can take 3 comma 9 at separate, separate it out like that, and again take a comma, yeah, like this. Okay, then now merge them back together in sorted algorithm, that is we get 27, that is I will write it here, that is 27. Okay, the first one, then yeah, it's comma, then 38, then we get 43. Okay, this one is the first one, and the next one, that is 3, 9, 10, 82. Okay, this is the last one, and then we get our final merge array. Just a second, I will write that final, yeah, final array we get is 3. Let's check one by one, that is first 3 comma 9 comma 10, then 27, then we get 38, then we get 43, and the last one, that is 82. Okay, so this is the our sorted array using merge algorithm, that is, or we can say merge sort. So merge sort is much more efficient for large data set with the time complexity of big O n log n. Okay, making it suitable for real world applications such as sorting large list, or we can say data streaming as well. Okay, the real world for this, like for insertion and merge, is, let's take a first example of insertion sort. It's often used in application whether the data is nearly stored or when new data is added frequently. Like just move to our PPT. The first one, that is the example for we are taking real data streaming, like a real time data streaming. Okay, we use insertion sorting. Okay, where only a small number of elements need to be resorted. Okay, and about the merge sort, it's used in external sorting when data doesn't fit into memory, and it merge operation in databases make it ideal for processing large data set efficiently. Okay, so in today's lecture we will cover only two things. First one is the insertion sort and another one is a merge sort. That is, insertion sort works well for small or nearly sorted dataset, while merge sort is much more efficient for large data set due to its time complexity, that is big O n log n. Okay, this is known as nothing but the time complexity of. So remember, choosing the right sorting algorithm depend on the nature of your data and performance required. In the next lecture, we will explore more advanced algorithm like quicksort and heapsort. So thank you for watching and don't forget to like, subscribe and share. So see you in the next one.